Welcome back. In Module 1, we looked at the building blocks of microeconomics, how individuals and firms make decisions in isolation. Now, in Module 2, we're going to bring these decision makers together to see how their interactions create market outcomes. We'll move through partial equilibrium analysis, game theory, non-competitive environments, and finally, the tricky world of asymmetric information, including auctions and screening. By the end of this module, you'll be able to explain not only how markets reach equilibrium, but also why they sometimes fail. 1. Partial equilibrium analysis. Let's start with partial equilibrium. This is the study of equilibrium in a single market, holding everything else constant. In other words, instead of looking at the whole economy, we zoom in on just one product or service. Imagine the market for cocoa beans in Nigeria. The demand curve tells us how much cocoa buyers are willing to purchase at different prices. The supply curve tells us how much cocoa farmers are willing to produce at those prices. The point where these two curves meet is the equilibrium price and quantity, the point where the market clears. Why is partial equilibrium important? It's a simple yet powerful tool for predicting price and quantity changes when conditions shift. It helps policymakers analyze the effect of taxes, subsidies, and regulations in a specific market without getting lost in the complexity of the entire economy. For example, if a new pest-resistant cocoa variety increases productivity, the supply curve shifts right, lowering prices and increasing quantity, all else being equal. 2. Comparative statistics, understanding market changes. Partial equilibrium becomes even more useful when we use comparative statistics, comparing two different equilibria before and after a change. Let's say the Nigerian government introduces a subsidy for cocoa farmers. This effectively lowers production costs, shifting the supply curve to the right. Comparative statistics allows us to clearly show the old equilibrium price and quantity and compare it to the new equilibrium after the policy change. This kind of analysis is the bread and butter of microeconomists. It's how we predict the consequences of changes in technology, policy, or market conditions. 3. Market structures beyond perfect competition. So far, we've often assumed perfect competition, many buyers and sellers, identical products, an easy entry and exit. But in reality, markets take many forms. Let's run through the big four. A. Perfect competition. Many small firms. Homogeneous products. Price takers, no single firm can influence price. Economic profits are zero in the long run. B. Monopoly. A single seller. Unique product with no close substitutes. Price maker, the firm sets the price by controlling supply. Potential for long-run economic profits. C. Monopolistic competition. Many sellers. Differentiated products, think different brands of bottled water. Some control over price, but competition keeps profits in check. D. Oligopoly. A few large firms dominate the market. Products may be identical or differentiated. Strategic behavior is key. This is where game theory comes in. 4. Game theory, strategic interactions. When there are only a few major players in a market, each firm's decision affects the others. This is the domain of game theory, the study of strategic decision-making. Let's start with the prisoner's dilemma, the classic example. Two suspects are arrested. If they both stay silent, they each get a light sentence. If one confesses and the other stays silent, the confessor goes free and the silent one gets a heavy sentence. If both confess, they both get medium sentences. The rational choice for each is to confess, even though they'd both be better off staying silent. In markets, the same logic can lead to price wars, advertising battles, or collusion. Nash equilibrium. A Nash equilibrium occurs when no player can improve their payoff by unilaterally changing their strategy, given what others are doing. For example, if two petrol stations are side by side, both setting the same price, neither can gain by changing their price alone unless they expect the other to change too. Repeated games. In real markets, players interact repeatedly. This allows for strategies like tit for tat, cooperate unless the other defects, then punish them in the next round. This can sustain cooperation over time, as in cartel agreements. 5. Non-competitive environment and market power. Not all markets are efficient. In fact, many suffer from market power, when firms can influence prices and output. Sources of market power include control over resources, patents, network effects, or government regulation. Consequences often include higher prices, reduced output, and lower consumer welfare. For instance, if one telecom company controls most of the network infrastructure in a country, it can charge higher prices than in a competitive market. 6. Asymmetric information, when one side knows more. Markets work best when buyers and sellers have the same information. But in many cases, one side knows more than the other. This is asymmetric information. Adverse selection. This happens before a transaction. Example, in the used car market, sellers know more about the car's condition than buyers. If buyers expect a high risk of buying a lemon, they'll only be willing to pay a low price, driving high-quality cars out of the market. Moral hazard. This happens after a transaction. Example, with car insurance, the insured driver might take more risks because they are protected from the full consequences of an accident. 7. Mechanisms to overcome asymmetric information. Economists have identified several ways to reduce the problems caused by asymmetric information. Signaling, the informed party takes action to reveal information. Example, a university degree signals a student's ability to employers. Screening, the uninformed party designs mechanisms to induce the other side to reveal information. Example, an insurance company might offer different packages to encourage customers to self-select according to their risk profile. 8. Auctions, competing for goods. Auctions are a special market format where prices are determined by bids. They are especially relevant in settings like spectrum sales, art auctions, and government procurement. Common auction types. English auction, open ascending bids, last bidder wins. Dutch auction, descending prices, first to accept wins. First price sealed bid, highest bidder wins and pays their bid. Second price sealed bid, victory, highest bidder wins but pays the second highest bid. Auction design matters because it affects how aggressively people bid, how much revenue the seller gets, and how efficiently the goods are allocated. 9. Bringing it all together. Microeconomic theory isn't just about drawing curves, it's about understanding human behavior and strategic interaction. We've gone from simple, isolated decision-making in Module 1 to complex, interconnected markets in Module 2. You now have the tools to analyze how markets reach equilibrium, predict the effect of policy changes in specific markets, understand how strategic interactions shape outcomes, identify when information problems may cause markets to fail and how to fix them. Microeconomic Theory I is the foundation for more advanced work in economics. The models we've studied aren't perfect, but they give us a systematic way to think about problems, make predictions, and evaluate solutions. As you move forward, keep in mind that real-world markets are messy. People are not always perfectly rational, information is rarely complete, and power is often concentrated. But with the framework you now have, you can cut through the complexity and focus on the key drivers of economic outcomes.